I hope the plan test went well. Plan Explore, I should say, went well for you guys. Um, if you're watching this, I guess before Wednesday, then you haven't taken it yet. But most of you are probably watching this Wednesday, so hopefully that went well. And I'm gonna try and make this video pretty short, but it's gonna be a little bit different. So a lot of this is gonna be a review. I want to make sure we know what median, perpendicular bisector, altitude, angle bisector, all four of those things, what they do, how they affect a triangle. Again, they're all that middle segment in the triangle, but each one does something a little bit different. Some have a combination of things. So what I'm going to have you guys do is fill in which one's which, first of all. Tell me which one of those four is each one. You can just write it in the box. And then I want you guys to be able to do number 2, 3, and 4 for tomorrow. I'm going to check these at the beginning of class. We're going to go over them. We're going to talk about them. But I'm going to walk around the room. I'm going to check to make sure your work's done, your answers are there, and hopefully you do have the correct answers. This is all review from days 1 and 2. So if you need to go back and watch days 1 and 2, or go look at your notes, do that. But 1 through 4, you are more than capable of handling. You can either do that now, or you can do it after the video, whichever you want to do. What we are going to look at as something new is the mid-segment theorem. Okay, and what that says, and we're just going to look at only this today. When a segment connects two midpoints, which is why it's called the mid-segment theorem, when a segment connects two midpoints of the sides of a triangle, then the mid-segment is parallel to the third side and half the length. So say this is 4, that's 8, and they're also parallel to each other. So I can draw those triangles a little bit better. So let's mark them like this. Still not very good, but hopefully you guys get the idea. Okay, so if we look at some examples, I'm going to have you guys do a couple of these. I'm going to do a couple with you. Probably have you guys do one for the beginning of class. Example 1. Find the measure if RK is a mid-segment. Again, easiest way to do this is instead of just trying to guess what's what, go ahead and mark everything. So you know that these are congruent. You know that these are congruent. You know that these are parallel. Okay, that's going to come in handy here in a second. First thing we can find, if ARK, and once we do one of these, I'd recommend putting it on the diagram and then going back and filling this in, but just to give you an idea of what we're going to be looking at. If we want to find the measure of ARK, that's right at where R is. So we're trying to find this measure right here. These are parallel lines cut by a transversal. Should ring a bell. This matches up with 52. Those are corresponding angles, which means that's 52 degrees. So that's not going away. Angle B, same idea. It's corresponding with angle AKR up there at 63. There's angle B for you. Angle A, okay, so let's look at the whole big triangle. So we have angle L, B, and A that make up the big triangle. So L is 52, B is 63, so that's going to give us 100, so we're going to say 52 plus 50, or 63 plus 52 is going to give us 115 degrees. So then we know that A has to make sure we add up to 180 with that. So 180 minus 115, that would get us 65 degrees. Okay, so that would be 65 degrees for A. So there are angles you can find. You can also find the sides. The sides are probably a little bit easier. So RK, if LB is 16, remember what we said is that's half or twice, going back the other way, that's twice the segment of RK. So if LB is 16, RK has to be 8. Okay. BK has to be 9 because it split that side in half, and AL, be careful what I'm looking for, not AR. AR is 7, but AL then would be 14. So everything's half. So RK is half of LB. We know that AK and KB were cut in half there. Same thing with AR and RL. And then again, we have those corresponding angles. We have a transversal in there, so make sure you're using that as well. I want to go through this one with you guys, but I want you guys to try and work ahead and see how much you can do in example 2. There's a lot going on. Again, I wouldn't try and go in order of what I have over here. I'm going to get you guys started actually, and then I'm going to have you finish example 2 because there's a lot, but I'll get you guys started. So we know that we have angles of 74, 63. Okay, if you want to start with angles, that's fine. Start with sides. I wouldn't bounce back and forth though. I'll start with angles. 74 degrees, 63 degrees. That's going to give me 137 degrees, which means this has to be 43 if you do 180 minus that. Okay. Now you can kind of decide where you want to go. Well, if we know those are 74, 63, and 43, what else can we find here? We know that these are parallel lines. Okay, so that's going to help us out here. Okay, you got to kind of look at the bigger picture. Okay, if this is 43 degrees, we also know that this is 43 because we have two parallel lines cut by that transversal, so they're alternate interior. If you look at it, they look the same, which in this case works. So that's 43. This side's 43 degrees as well. If you kind of turn the paper, you can see that you have another set of parallel lines that are cut by a transversal. So we are also going to go back the other way. We know this is 63. This is 74. Parallel lines cut by a transversal. Okay, once you do one of these, you'll be alright with them. Okay, we're almost done here with these angles. If we know that's 43 plus 74, so far we're at 117. So our leftover is going to be 63 degrees. Okay, over here we have 63 plus 43. That's going to be 106 degrees. So then this would have to be 74 degrees. Not a coincidence. Okay, we have a bunch of small little triangles that are all congruent to each other. And then to find these angles up here, 63, that's corresponding, 74, that's corresponding with angles U and E. And then to find the last one, angle B, you can probably look at the other ones, or you could do 63 plus 74 and subtract from 180. Or you just can look, like I said, at the other ones and know that this is going to end up being 43 degrees. So there you have all your angles. Okay. Let's go back and mark our sides now. So we know that these sides were cut in half. We know that, let's see, if you look at this example of here, you can see what we did exactly. Oops, I don't want to do that. These sides are cut in half. These sides are cut in half. Okay. And then let's see what else we know. So I know that each one of these are 14. I know if this is 12, that's 12. I can't do those little fancy things. Let's try again, actually. Yeah, see, they're pretty bad. And we know this is 24. If VL is 10, I know that this whole side is then 20 because it's half of that other side. Okay, so we have a lot going on. Tons of information. A lot of patterns that you'll see. If you notice again, we have 4 triangles that are all the same. Okay, they're just turned in different directions. So you'll get the hang of these after a few times. But make sure you guys are looking at this as kind of a reference. Go back and fill in the information. Just getting the habit of, okay, what angles where, which one's which. Make sure we know which one to look at. I'm going to do example 3. Okay, and we're going to save example 4 for tomorrow. Solve for x, y, and z. Alright, well, I know that I have a bunch of congruent sides. Okay, so we know that we have these two parallel lines that are congruent to each other. So to solve for x, okay, or to solve for y, to solve for z, we can really start anywhere we want. Alright, what we said before was that the mid-segment is half that bottom segment. In other words, you need 2 of the mid-segments to equal that bottom line. Okay, so we're going to go for z first. Doesn't matter what order. So 4z plus 2 equals 5z minus 8. So subtract, add 8. z is 10. Okay, so we've taken care of that. To find, let's go y and just go exact opposite of alphabetical order. Okay, so we have y is here. Notice that that's corresponding with this angle here. So to find y, we're going to say negative y minus 2. Corresponding angles need to be congruent, so we set them equal. Add 2. And to get rid of that negative, divide by negative. So we have negative 62. Which if you plugged it back in, you'd get negative of a negative is a positive, so 62 minus 2 would give you 64. Okay. I have no idea why I did that. Whoops. Hopefully you guys saw that. 64 plus 2 is 66. There we go, and that's why you always check your answer. As I was doing it in my head, it didn't make sense. Negative 66, so opposite of negative would be positive 66 minus 2. Now we get 64 degrees up there. Phew. So that's 64 degrees. To find x, we want to make sure that we have, not red, I already used red. X plus 64 plus 43 equals 180. Or some of you probably are just doing 64 plus 43 and subtract from 180. It's really the same thing. So x plus 107 equals 180. Subtract. So x is 73 degrees. Okay, so going in, sometimes you're forced to go in a certain order. Like I had to find y before I could find x, but you could have found y or z first. It didn't matter. X did have to come after y though. Again, we're going to save example 4 for class tomorrow. You guys will do that when you're in your groups, so you can start taking a look at it, maybe marking some things that you know, and then we will talk about that one tomorrow. Peace.